This is Algebra 2 with Trig. We're working on section 8.1, which we're calling 3A.1. We're going to do inverse and joint variation. Direct variation is considered a linear equation, y equals a of x. Another way you can manipulate that equation is to divide the x underneath to have y divided by x, and that would equal a constant number. That would be direct variation. Another type of variation is inverse variation. So here we're going to have y equals your constant number divided by x. That is inverse variation. You could manipulate that to get the a by itself by multiplying the x to both sides of your equal sign, and that would give you your a by itself. So this constant a term is considered a constant of variation. Y is said to vary inversely with x. So if you look here, y equals a over x. So y varies inversely with x. That means x is going to be dividing the a, or you could consider y to be multiplying the x. However you want to think of the equation being written. If y varies directly, that's going to be y equals a times x, or you could consider that y divided by. So when we come down here to look at our different forms, we know direct variation is when we have y divided by x equals a constant term. Inverse variation is your y and your x are multiplying to get a constant value. And then neither would be something, maybe you are adding your x's together, or you are adding your x to a constant value. Neither of these, direct or inverse, would be in that format. So we first look at this and we get a little confused, and we think, well, that's very much like the adding one. But notice you can add your 3x to the opposite side. So now you have y equals a constant term times x. That should be enough for you to know that's direct variation. Or you could divide by the x to notice that this is y divided by x that equals a constant. This is considered direct variation. Here we have something that might look like a constant number division, but you want to pay attention to where the y is at. Here we would have to multiply by the y to bring that up next to the x. And this has our multiplication pattern. That is our inverse. Or you could write that as your 3 divided by x. You could divide your x underneath. So that is going to be inverse. Inversely. And then here, this would be the adding one, where even if you were to subtract that to the other side, y equals negative x with a positive 5, we can't get the x and the y to be multiplying each other. We can't get the y and the x to be dividing each other. So this is neither. So those are 3 different ways an equation can be written. Now we can look at a table. In a table, we know what the pattern is supposed to be. We'll take a look at direct variation. Direct variation is where you take your y term and you divide it by your x term, and we should get a constant number. So if we get a calculator, see if I can get this to fit in here. We take our y term, which is 21, and we divide that by 4. We get 21 divided by 4. That's 5.25. That doesn't mean anything yet. We need the other ones to have that same quotient. So 14 divided by 6 is going to be 2.3. So that should be enough to show us that this isn't working. You could test it again. 10.5 divided by 8. And you notice that we're getting a different value every time we do this. 7 divided by 12. None of those is a constant value. We need a constant value every time. So now let's look for inverse variation. That's when you multiply your x and the y together. So here we have our 4 times our 21, and that equals 84. Then we have our 6 times 14, and that equals our 84. And our 8 times 10.5. And that equals our 84. And our 8.4 times 10. Of course, we move the decimal spot over 1, but that equals our 84. And 12 times 7. And that equals our 84. So there's an example of getting that constant number through the multiplication of your x and the y. That means this table is showing inverse variation, not direct variation. Here we're going to write some equations. The variables x and y vary inversely. So if they vary inversely, that means we're going to be able to write it as y equals a over x, or we can write it as x times y equals a constant number. You can use either method. They're the same thing. So x and y vary inversely, so that's why we're using this pattern, and y equals 15 when x equals 1/3. So when x is 1/3, y is 15. That equals a constant number, so that constant number is now going to be 5. So we're going to write another equation that relates x and y. So we're going to be able to say that x times y equals 5, or you could write it as y equals 5 divided by x. Those are both the same thing. What are we going to get when x is negative 10? Well, what is y when x is negative 10? Y equals 1/2. So we're using our given information to figure out what A is, then we're using the A to figure out another set of data points. Here we have the driving time between two specific locations varies inversely with the average driving speed. So that means that rate times time is going to equal your distance. Distance equals rate times time. It's a pretty common formula. So we're going to have Chicago to Minneapolis is about 400 miles. Write a model that gives a driving time, which is your T in hours, between Chicago and Minneapolis as a function of the average driving speed. So we're going to have R times T equals our distance. Write a model that gives the driving time. So we're going to divide by the R, so that gives us our driving time as a function of the speed. So then we can look at a table, make a table showing the driving time for the average speeds. R is your driving time. It's called your rate. So if we have a 32 as your rate, or a 40, or a 50, or a 60, we can calculate what the time is. Our time is going to be 400 divided by 32. We have 400 divided by 32. That comes out to be 12.5. We have 400 divided by 40, and that comes out to be 10. 400 divided by 50, that comes out to be 8. And 400 divided by 60, that comes out to be 6 2/3. 6.667. So if you're looking to see of where do we get our constant value, that is when we multiply, coming back to our equation, distance equals rate times time. If you multiply your two values together, 32 times 12.5, we get our 400. 40 times 10, we get our 400. 50 times 8, we get our 400. So there's our constant number. So recognizing what we've already talked about, the general equation for inverse variation is y equals a over x. And it can be written by multiplying the x to the other side, multiply x to both sides, gets the a value by itself. So if you multiply an x and a y and get a constant number, then you know that this is an example of inverse variation. This tells you that a set of data points, x and y, shows inverse variation for the product of x and y. That they would be a constant. Or in a real world situation, it would be very close to a constant. Here we have cartons for a manufacturer, moving cartons, in a variety of sizes and shapes to accommodate the variety of objects. The table compares the area of the bottom of the rectangular carton with the height for the 4 available cartons. They all have the same volume. They got to have that constant result. So we know that the area times the height is going to be the 50 times the 24, and that gives us 1200. So if we're going to write a model for h as a function of a, that means we're going to get the h by itself. We're going to divide by the a. We're going to have h equals 1200 divided by the area. So predict the height of a carton with the same volume. So we're going to use the same table, the same formula, that has a base area of 75. So the height when the base area is 75, 1200 divided by our 75, we get 16. So we have the height is 16 inches. And then to finish up, we have joint variation. Joint variation occurs when the quantity varies directly, so very much like direct variation, with the product of two or more quantities. So here's an example of z equals a times x and y. Z varies jointly with x and y. So if you're varying jointly, you're going to multiply a times your x and your y. P varies jointly with three different variables. So the variable z varies jointly, which pretty much equals a, and x, or with x and y. So we know the pattern of what we're working with our variables. So when z is 60 and x is -4 and y is 5, what's x, or what's z? This should be a z over here, by the way. What is z going to be when x is 7 and y is 2? Well, if we divide by -20 and divide by -20, these all cross out, and we get -3 for a. So z is going to equal -3 times 7 times 2. 21 times 2 is -42. So now just paying attention to the words varies inversely. So varies inversely, recall, is going to be the r times s equals a constant, or r equals your constant divided by s. Either way you decide to write that up. Jointly means that you're going to be multiplying. Z varies jointly, so equals a, with x and the square root of y. So you could rewrite that to get the constant by itself if you wanted to divide by both the terms. But then typically we don't like to leave a radical in the denominator. It's kind of messy. So this will be fine. Varies inversely with the cube of q. So P times the cube of Q is going to equal your constant number. So P equals A divided by the cube of Q. M varies directly. So M varies directly, that means equals A, with the square of N, and inversely with P. So remember, inversely, we wrote the two variables multiplying each other. So we could write them multiplying each other, or you could write it as M varies directly with N squared and inversely with P. So inversely essentially means you're going to divide it into your A, and directly means you're going to multiply it into your A. Last one, jointly, Z equals A, U and V, and inversely with Q, with the square of Q. So if you would like to write that out here as multiplying, or you can get your Z all by itself completely. For inversely, it would be dividing into the A, and directly or jointly, meaning two variables or more, are multiplying the A. That's all.